Okay, welcome. Hey, this isn't our course, although some of you are in that one. I sent out kind of a longish announcement when I posted the practice test. So I just want to talk about some of the key things. So just to save me some writing, I'm just going to bring it in. Okay. So make sure you got the announcement. But if you didn't, here it is. I'm gonna crop this a little bit here. I'll keep my sign off, why not? Okay. I feel really bad because I didn't realize I put a test right after the Diwali celebrations on campus. And so I had a lot of people email me and say, hey, that's not cool. And so I thought, okay, I got to figure something out. It kind of messes with the flow a little bit, but what we'll do is we'll do the review on Thursday because it took me a long time to make a practice test that I was happy with. So Thursday, you have to submit it. Just for me to see that you tried it, right? It doesn't have to be right or anything like that. I'm not going to look at what you did really. It's just so to show me that you tried something, right? And so for Thursday, right? This is for Thursday. Okay. Since I sent out the announcement, I made a decision. We're going to abandon the textbook that we're using. So that means kind of abandoning what we've been working through. It's not really been fair to you guys. You guys have been working really hard, and it is really good that we worked through it. But because we come from so many different math backgrounds, it hasn't really been what we expected it to be, right? And so the decision I've made, and if you don't like it, then definitely let me know because I want to know that. But if you guys are okay with it, then what I want to do is basically go back to the last part of Stat 230 and just elaborate some more on, testing for proportions, maybe using chi-squared tests, testing for means, maybe going deeper into ANOVAs, regression, so hypothesis testing for regression, those types of things. So there's lots that we can do there. And for me, it is just the idea of getting to switch to something like that is really fun. So I hope that you're okay with it. It's what I love doing. And so hopefully it's going to be a little bit better, a little bit more reasonable. You've worked really hard, and I am so proud of you guys for what you're going through. And so now I've made the decision. I don't know if I'm going to get in trouble. Hopefully not. I don't think so. Eek emoji. No, it should be okay. But I think it's going to be better for everyone. And so I did some digging, took a little bit, but it turns out that all of you took Stat 230 with Jenna. I just realized that way too close to class, but I sent her a text saying, hey, what parts didn't you get to? And so hopefully she'll text me back, and then we can kind of do a little bit of review because it was a while ago. And then we can just kind of fill in the gaps from there with the rest of the term, because that's what I think you'll use more. Okay, we are going to be using R, especially once we get into ANOVAs and stuff like that, regression. Then we definitely need to use R. So we're going to use it quite a bit. It's good because even if you haven't been working with R in STAT 230, there's no lab component in STAT 230, unfortunately. So you might not have, but you have been working through those labs, and so you've got a reasonable understanding. And so we're going to pick up from there and just kind of keep going a little bit deeper into the material. So what I posted was, I just found it pretty recently, this R practice for learning statistics. It is just for reference, but someone has done a really great job of just doing clear and concise, just basic R code for doing, kind of run-of-the-mill stuff. Okay, and they've even incorporated, I think they're using Data Camp. They've got little notes there, but so you can actually run the R code on the website. Okay, so fancy stuff. I got to figure out how I can do that, or just use this one. Seems a lot easier. So they've done a really great job, and they've got videos. And he just seems, from what I've seen, it looks just really clear and concise in, different things that you might want to do with R, just the basics. So he talks about the QT, the PT command, and then he's got this cute, now you try. And so you can type in your code there, and it's just a little R code chunk, and then you can run it by hitting that green run button. And then I think it'll give you some feedback. I didn't try it too much, but even things like calculating confidence intervals, right? He's got a video to start, and then they take a closer look at the code, which of course, well, not the code, but the calculation. That looks nasty, right? But it's just a t distribution. As soon as we have a mean, we have a t distribution. Alpha over 2 is our area in the tail, in one of the tails, and then we have n-1 degrees of freedom. So stuff like that, I would like to do a quick, not quick because it is likely going to take me all class, but just an overview of things that you might remember from STAT 230, might be a little rusty because it was a long time ago now. And so it's always nice to do a quick review. This is not on the test. So let's see here. So I changed our little, I kept flip-flopping back and forth. And I was going to do section 2.2. If you have read section 2.2, you'll be happy that we're not. We're doing we should have been doing transformations of 2 variables, and it involves matrices, and it just got out of hand. So then I said, no, you know what? Let's do something that we actually want to be doing. And so today I just want to do review of hypothesis testing and all the different streams that you've already seen. And that's not on the test. And then we'll do the review back to the old material. We'll call it the test 1 material on Thursday. That's when we'll go through that practice test I posted together. Okay. And then lab 6, I've decided just do the video just like we've been doing. I think that'll be good. And then next week, we're running out of time. That's the problem. We're going to have test 1. I know it's not a problem. You're counting down the days. Oh, we're in November. As soon as we hit November, I usually feel like, oh, the term is over, whatever. Just flies by. And then December is usually really fun, right? Final exams, but you don't have classes. You're just hanging out. You're stressing. You're studying, but you're also having fun, I hope. So then we'll have test 1. And then remember, there's no classes on the Thursday or the Friday, right? So of course, you're off then. Okay, and so I think that's a nice place to have test 1 anyways. We are to have test 1. But we committed to 2 tests, otherwise I would probably just do 1, but here we are. We're just making it work. And then we'll have kind of 3 weeks. I'm thinking the test will be in that last week because it is going to be less, or it's going to be 15% of your grade, so it's allowed to be in the last week, but nothing more than 15%. So, but that way we can cover, you know, a good chunk of material. Let's see here. Okay, so I did kind of a rundown of due dates and things to keep an eye out for. We're not doing this anymore. Review of Stat 230 instead. And then, yeah, I know. So what we've seen, that's as bad as it's gonna get. So I know, because I just feel so terrible. You guys are working so hard, and you know, it's a lot of calculus, and it's a really tough chunk of material. It is important. If you're going to do stats, of course, you should do a course like this. I don't think that we were ready for this. So, so that's okay. Me neither. So it's been a long time. So I'm hopefully you're okay with this change. If not, you can keep reading the textbook and tell me what you think. Okay, so Friday, I'm just going to stick to the work through a lab on your own because, okay, yeah, you loved it. And so I think that's working fine. No one wants to come to class on a Friday anyways. I'm here, but no one does. And then just a note, so November 8th is the Monday before the test, okay? And so here, this just as a note is the Monday night before test 1. I tried to pick questions where you have answers in the back of the book. Okay, but if you don't have answers for those assignments and you want me to check the assignments, because of course, if you're handing it in the night before the test, then you want to make sure that you worked through it correctly. And so if there's anything that you're not sure of, just send it to me and I'll have a look. Okay, and so but I also didn't want to do them before because then you're feeling cramped for time and it's a busy time for everyone. And I don't know, I'm just trying to make it work. And then of course, we'll have test 1 during class time. Okay, so I'm going to post a PDF just like I did with the practice test. And then you'll have a grade scope Dropbox where you submit your work when you're done. Right, and it's going to be open during the class time. I might do a little bit after class time just in case you need some time to scan and upload your work, but the test itself is supposed to be between, when do we meet? 12:30 and 2. I can't remember. It's right now. And then, of course, no classes on Thursday or Friday, but Lab 6 is due on the Friday. Okay. And so I've posted the practice test, which we'll go through together on Thursday. Upload your work for completion marks as a bonus assignment before class on Thursday. So basically what that means, a bonus assignment in this case is you upload your work and you get 1 mark out of 1, and that'll bump out whatever your lowest assignment mark is, right? So if you're missing an assignment, then of course this is a good place to start. In terms of the completion, right, I want to see looking for a reasonable amount of effort in your attempt. Okay, you don't have to, it doesn't have to be right, it doesn't have to be 100% complete, right? But I'm looking, you know, did you spend some time on it? In this case, right, you have the class time to do it. So it would be a good idea to time yourself, right? Study for it beforehand. I wouldn't use this as a study tool, right? I would kind of study our other stuff and then head into it and see what you can do, right? And so looking for a reasonable amount of effort on each question. Yeah. What? So I don't know. So this page keeps not behaving. Okay. So I'll do a recap here. For the remainder of the course, we will go through kind of the deeper parts of Open Intro. So I'm assuming that you used Open Intro maybe in Stat 230. We'll see in the chat, or maybe you guys had a different textbook. Yeah, you used Open Intro. Okay, nice. So what I want to do is, I'm still waiting to hear back from Jenna, of course, but today we're just going to do a review, and then I'll have a pretty good idea of what to fill in the gaps for. So for the remainder of the course, we will work in Open Intro to fill in the gaps from Stat 230. Yeah. So you might have read Open Intro. Now I'm going to pull from some other resources. Oh, really? Wow, fancy. Okay, so Sean's notes, Jenna's notes, probably about the same. And I'm sure they're very similar to the textbook. Did you guys get to non-parametric tests? So things like the Wilcoxon signed rank test, I think it is. Did you guys do weird stuff like that? Okay, so that's good. The Mann-Whitney test, I can't even remember what it does. Okay, nice. How about the 2 main ChiSquared tests, which is for independence and what's the other one? Can't remember. Okay, nice. Wow, you guys really covered a lot of ground. Dang. No, that's good. How about ANOVAs? Okay. Not leaving a lot for us to cover here. How about multiple regression? Sort of. Cha-ching. How about hypothesis testing for regression? Okay, good. How about hypothesis testing for correlation? Okay, this is great. Probably not, right? That would be like deep tracks. Logistic regression? Probably not. Okay. Then I have some great news, because then we just are going to focus on the fun stuff, regression. We'll incorporate some ANOVAs in there, but oh yeah, that's fake. So yeah, that was, it is the original outline. That's just what Claude sent, but then he was like, oh yeah, but that's not true anymore. Okay. So yeah. But basically that's what I want to get into more. But just kind of referring to it, since we have the list here. So topics include simple and multiple linear regression, correlation and nonlinear regression, ANOVAs, factorial experiments. We'll skip it. Non-parametric methods. It looks like you guys covered those. So those would be whenever you're working with categorical data, typically. So chi-squareds are considered non-parametric methods. The Mann-Whitney U test, the Wilcoxon-signed RAM test, those are all non-parametric methods. So you've actually seen those. And then the quality control charts. Sure, I guess we could do some quality control charts. Then we'll be off to the races. Okay, so I think that this will be a good change. And yeah, finally hearing something sort of familiar. Yeah, it's good. And I think we'll have some fun with it. So basically, I just want to fill in the gaps. And even if there's, yeah, well, there might be a little frustration, but at least it's reasonable. And so I'm really happy about it. And I hope that you are too. But so it doesn't hurt to do a little bit of review, because I remember at the beginning of the term, you know, you guys were asking questions like, okay, well, I'm not really 100% sure on when I use a chi-squared test, for example, or I'm maybe not able to or comfortable figuring out when I should be using maybe an ANOVA, right? Something like that. And so what I want to do is just kind of give a quick overview of things that you covered in Stat 230, more or less, and then we can talk a little bit more about it. So today is just kind of, you know, getting into this new part of the course, I guess, because I'm changing it completely. I'm ripping it up. Okay, so there are kind of two parts of inference, right? So inference can take the form of confidence intervals, or it can take the form of hypothesis testing. And so I guess what's most fun about this change for me is I can blab about all this stuff all day long. No one can stop me. And so I feel more comfortable too. So I can just, oh yeah, blah, 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 blah. So just as a quick review, right? I shouldn't say review, an overview. Okay, so not necessarily a review, but an overview is that inference can either be confidence intervals, yeah. That's when we're looking for a reasonable range for our parameter that we're trying to estimate. I say that vaguely, parameter is just anything from the population, right? And so it depends on what we want to talk about. That can be something that we know, like the population mean, the population proportion, the population difference in the means, or maybe it's something we haven't looked at before. Maybe it's the correlation, the population correlation, right? So it can be anything in general. And what we need to remember is that a parameter is something from the population that we're trying to estimate. Okay, and so confidence intervals. Hey, doesn't this look weird? I'll do this. I'll clean this up a little bit. How about that? Inference can be, maybe I'll make these dark blue. Now I'm just getting nitpicky. There we go. So confidence intervals are when we establish, so they establish a range of plausible values for the parameter that we are trying to estimate. Okay. So, and just as a reminder, right, a parameter is any measurement from the population, right? Population parameter. P and P go together. And remember the sample and statistic, right? A statistic is any measurement from the sample. So any measurement from the population. Okay. Whereas hypothesis testing what does it do? It tells us whether there's a statistically significant difference between a statistic and the hypothesized parameter. Okay, so that's in general. So it establishes whether there is a statistically significant difference, significant difference between the sample statistic, or just the statistic, right? Because that is from the sample, between a statistic and the hypothesized parameter. Okay. And of course, a statistic is any measurement from the sample. So what we need to keep in mind is that, okay, so hypothesis testing, that's kind of a more formal approach to seeing if there's a statistically significant difference, right? Is there a difference between my sample and the population that I thought it might have come from, right? Or usually what we want to say is, well, my sample is so different from that other population that I don't think it came from that population. right? And so it's unlikely that it came from that population. There's still a chance it did, but it's unlikely that it came from that population. So my conclusion is that it came from another population, right? Whereas, so that only tells us, yes, there's a difference. No, there's no difference, right? But the confidence interval lets us say what the difference might be, right? And so that's the difference between the confidence intervals and the hypothesis testing. Here in hypothesis testing, we're only really able to say, yes, there's a difference, or no, there's no difference, right? But we don't know what that difference is until we build a confidence interval. So let's jot that down. So a hypothesis test now, usually I just abbreviate HT, and maybe I should hypothesis test and CI for confidence interval. A hypothesis test is used to establish if there is a difference, but we need a confidence interval to know what that difference could be. Okay. But we need a confidence interval, so a CI, and I'll define it here, but usually I'll just go for it. But we need a CI to tell us what the difference would be. To tell us what the difference might be. Okay. Most of the time, if you're running analyses in R, it'll do the hypothesis test. So it'll calculate things like the t-score, right? Our test statistic. It'll calculate the chi-squared, but then it'll often just give you the confidence interval as well. And that's because we need to work with them side by side. So even though we separate them, usually we do both at the same time. Okay. Okay, so what we said was in Stat 230, we said, okay, well, we're going to split our types of problems into two main groups, right? We're going to deal with proportions, or we're going to deal with means, right? So if we have categorical data, typically we talk about proportions, and if we have numerical data, typically we talk about the mean. Okay, and so we've seen that too, right? Where we had discrete data, where that's going to be for our proportions, right? And then we had continuous data, so that's things like the mean, the normal distribution, all that fun stuff. Okay. So inference, I'll put it at the top, and what I'm going to do is I'm going to build this tree here, and I'm definitely going to run out of room, but I'm going to try my best. So inference, we split it up, and there are some other scenarios, but at its core, we can split data into two groups, right? Categorical, and of course, categorical data can be split into other types of kind of subcategories, right? And numerical data, we can split it into subcategories, but we're just going to look at the two main branches. So categorical data and numerical data. Categorical data, we typically analyze proportions, potentially plural. And numerical data, we're going to analyze means. Oops. And maybe I'll say analyze proportions, analyze means. I'm so impressed at how much material you guys were covering in Stat 230. They must have just crushed through stuff. I take forever talking about hypothesis testing and making sure everyone knows all the ins and outs, and it takes me forever, but it's important. So now I'm like, gotta keep up to those guys. All right, so for categorical data, right, we talked about, okay, well, we can have one proportion, one sample proportion, p hat. Okay. We could have two sample proportions. Maybe I shouldn't have the p hat there, because of course p hat is a sample proportion. But let's just stick to this, right? So one sample proportion versus, that's what I'll say, versus a hypothesized proportion. Bump that up. There. Two sample proportions. We typically compare them against each other, right? Or some difference in the, some value of the difference. Okay, so against each other, or some value of the difference. That's pretty rare that we do that, but it does happen. So I just want to leave it open here. So that would be things like P1 hat minus P2 hat equals 0.1, for example. If we want to know if there's a difference of 0.1 between the two, right, then you could set it to something that's not 0, right? So two sample proportions against each other, or a value of the difference. So for example, if H naught is that P1 equals P2, or usually I like to have P1 equals P2, but let's do P1 minus P2 equals 0. Make that look like a 2. Right, versus the null hypothesis that P1 minus P2 equals maybe 0.1 or something like that. We could look at a difference. We rarely do that. So it's rare that we do that, but it is an option, right? Whereas here, for the null hypothesis, oops. P equals P naught, where P naught is some null value or some hypothesized value that you want to compare your sample proportion to. Now, what you probably found as you were working through Stat 230 is all you really need is what's the null hypothesis, right? So what is the null hypothesis that I'm testing here, and maybe the alternative hypothesis, and what's the test statistic? Right? How can I calculate? How can I measure the differences? Right? And so by giving you the null hypotheses here, right, I'm basically telling you what the test does. So it tests, is P1 minus P2, is it significantly different from 0, meaning they're basically they're different, right? Or are they not essential, or are they not statistically different from 0? It means that they're essentially the same, right? And so it's been a while since I did any chi-squared stuff, but let's see if I can squeeze it on here. There are a couple of different chi-squared. So just like how you use the t test for different scenarios, the chi-squared is the same. So we can test independence, and I'm completely drawing a blank on the other two. We're comparing the observed versus the expected values. Okay, how can I? So we can compare multiple proportions. Or compare distributions. Oops. Using ChiSquared. Oops, that doesn't look like chi. Okay. So sounds like you guys worked on some chi-squareds. I don't think it hurts to go back and maybe review some of those, right? When should we be using them? Probably just working through some problems, right? Because most of the time when people contact me for help in statistics, it's usually trying to identify what tests can I do, right? Here's my data. Here's what I'm trying to figure out. I just can't seem to get a handle on what tests I should be using. Do I use a t-test? Do I use a chi-squared test? Do I use an ANOVA, right? And so that's the hardest part, I think. That's when people contact me. So we'll just kind of leave that for categorical data. There's lots of other things that you can do, but we'll just talk about the overview. So then we can talk about numerical data. Typically we analyze the means. And so we can talk about one sample mean, right, versus a hypothesized mean. And in that case, our null hypothesis, mu is some mu naught, right? Mu naught and p naught, those are just null values that we want to compare our sample mean or sample proportion to. Now, you might have tested one sample mean sigma known, sigma unknown. We're going to ignore the sigma known case because it's never going to happen. And it's basically just training wheels for figuring out what the Z distribution looks like and stuff like that. So I'm curious though, did you guys use Z scores for means? So something like one sample mean sigma known, one sample mean sigma unknown would sound familiar in that case. No one remembers. That's okay, maybe you didn't. Maybe you use the new age approach of starting with proportions because they follow a Z distribution anyways. Maybe that's where you're at. Okay, that's okay. So one sample mean versus a hypothesized mean, right? I'm gonna ignoring the sigma known case since it is unrealistic. Okay. So if I have one sample mean, I want to test it against some hypothesized mean. Or if I have two samples, then they could be paired. Or they could be just two independent samples. If they're paired, then you have this H naught that the mu diff or something similar equals 0. Whereas if you have two independent samples, then you have mu1 equals mu2. Or mu1 minus mu2, or mu1 minus mu2 equals 0. Depends on what you like. Some people like to set it equal to 0. They think it looks nicer. I actually like to have less writing, so mu1 equals mu2 means that mu1 minus mu2 equals 0, right? They're the same, so you can use either or. But I just like the symmetry of just having a thing equal to another thing. Okay. And so what we can do if we have multiple samples, so 2 plus samples, and maybe I should say just multiple samples. Then we test it with an ANOVA. And our null hypothesis is that mu1 is equal to mu2 is equal to mu k with k samples. Okay, so that's kind of where we'll head into a little bit more, just looking more at testing with multiple samples, right? And so just in general, right, here I've talked about how do I calculate my test statistic for multiple proportions. I use ChiSquared. For multiple means, I use an ANOVA. And of course, just as a reminder, for proportions, we use Z-scores. Right. So here, Z test statistic, or maybe I'll say test statistic is a Z-score. Okay. How you get that Z-score changes. It depends on the scenario. Do you have one sample? Do you have two samples? And here for all these up to 2 sample situations, then the test statistic is a t-score, right? Different ways of getting there, but then once you have a t, you know how to use a t. You can either use the t-table, or more likely you're going to have R calculate the t for you, and then it'll also spit out a p-value. And all you need to do is interpret the p-value, right? And so just a recap of hypothesis testing. Also because I know Sean, and Sean probably has it broken down into more steps. We're going to do the same stuff. I just don't tend to call them individual steps. So I just suspect that he likes to have more steps in his procedure. I stick to 4 steps, but you'll see we cover it does the same procedure. So I'd love to know if you had 4 steps. Let's outline the steps that I use, and then we can talk about the steps that you used. So step number 1 is to state your hypotheses. Right. A sub-step here would be determine if you have a one-sided or a two-sided test, right? And that comes from the alternative hypothesis, but I'm just going to leave that as just state the hypotheses. The second step is going to be do the test, right? Which is basically calculate the test statistic, but I think do the test sounds more fun, do the do. And so this is really just saying calculate the test statistic it's assumed that you're checking the assumptions before you're doing anything, right? And so maybe I should write that here. It is assumed you have checked the appropriate assumptions, gulp. Do you remember those assumptions? I'll outline them as we need them, but so it's assumed that you have checked the appropriate assumptions before doing the hypothesis test. Okay. So then you're going to state your hypotheses, and then you're going to do the test. So you're going to calculate the test statistic. And then the third step is, let's assume that we're doing a formal hypothesis test with p-values. Then, of course, you're going to find the p-value. Okay. So typically, these two steps are done in software, done using software. Typically done using software. Now we teach you how to do it by hand, right? Because it's important that you understand what you're telling your computer to do, but we're not going to calculate these things by hand, right? That's insane. Even if you had summary statistics, it just gets a little bit old. So we're going to be using software, which, could be R, Excel. There's tons of other ones, SPSS, could go on, but the list goes on, right? So there's lots of different tools, but we're going to use R because it's free and awesome. So, so find the p-value. Okay, so doing the test and finding the p-value is usually just one step using software. But then, of course, we have to state our conclusion. So the conclusion, for me, it's really important that the conclusion has 3 parts. First, you're going to compare the p-value to the alpha level, right? Is it less than the alpha level, or is it not less than the alpha level, right? Second thing, what does that mean? Whatever you said earlier, what does that mean in terms of your null hypothesis? It's really important that we remember that we're doing all this hypothesis testing, assuming the null hypothesis is true, right? And so that's true for any of these scenarios. Okay. And so our conclusion should have 3 parts. Compare the p-value to the alpha level, the significance level. Compare the p-value to the significance level. Which is the alpha level. Okay. So that's your first thing that you talk about. And there's only 2 options there. The p-value is either less than the alpha level, or it's larger than, or I like to say not less than the alpha level, right? 2, what does that mean in terms of the null hypothesis, right? And so your conclusion in terms of H0, right? That's important because we do all our testing assuming the null hypothesis is true. And maybe what I'll do is I'll kind of give you the two scenarios underneath here. So the p-value is less than the alpha level, or, and maybe I don't need this here, or the p-value is greater than the alpha level. Okay. So depending on what happened here, I'll use that to state my conclusion in terms of the null hypothesis, right? If the p-value by definition, remember, is the probability of seeing something as extreme or more extreme, assuming the null hypothesis is true. Now, what that means is the p-value is going to be the area in the tail. Okay. And so if the area in the tail, meaning you've moved so far out into the curve, assuming that the null hypothesis is true, then that's really unlikely, right, that the null hypothesis is true. It can still happen. And that's where type 1, type 2 errors come in. But so the p-value is really just the area in the tail, right? And so how far out into the tails did you go? And that's true for any distribution, right? A chi-squared is going to have this kind of skewed distribution, but so the F distribution, can't remember. I think it's true for both. But anyways, so you're measuring how far out into the tails did you go, right? And so you need some sort of threshold after this point, then you're considered extreme, right? And it's unlikely that the null hypothesis is true. It's still possible, but it's unlikely, right? And so that's that alpha level that says, no, after this point, no, reject H naught. It might still be true, but you feel confident rejecting it. So if the p-value is less than the alpha level, then what do? Then you have enough evidence to reject H naught. And I'm going to reword this, the p-value, because I want to have this kind of symmetry. So the p-value is less than the alpha level. So maybe I'll rewrite this kind of in words here. P-value is less than alpha. Okay. Then the opposite here would be that the p-value is not less than alpha. Okay. Which is really saying that we do not have enough evidence to reject H naught, right? So it's really important to keep track of these. We do not have enough evidence to reject H naught. For me, I'm really, really picky about, I do not want to see the word accept anything, okay? We can never accept a hypothesis because there's always a p-value probability that we're wrong, okay? So I'll write that after I do the third part of our conclusion, which is, of course, the conclusion in terms of the question. That's what we're here for. But usually people are so tired by that point, they forget to tell me the conclusion in terms of the actual question. You wouldn't do that if you were submitting a report to a client, I don't think. You wouldn't, oh, so I have enough evidence to reject H naught. There you go, have fun. Doesn't mean anything to them. So our last step is the conclusion in terms of the question, right? What does it mean to reject H naught in terms of the question, right? What does it mean to not have enough evidence to reject H naught? Okay. And so if we think about, so consider, let's look at proportions, because that's probably the easiest one, I think. I'd love to know if you guys started with z-scores for means or for proportions, but just to bring it back. But if you can't remember, that's okay. For proportions, nice. So let's take it all the way back then, because I think that's a nice place to start. So here you have your hypothesized proportion, all right? And then what you saw is some sample proportion p hat, maybe out here. So then the one-sided p-value, and let's just focus on the one side. Did you guys talk about one-sided tests and two-sided tests? One-tailed, two-tailed? Okay, so I just want to know what kind of lingo I can use and what I need to introduce. Okay, good. Because I know it's optional in the textbook, but I usually cover it, so, but that's good. Okay. All right. So you have some sample proportion here, and how does it compare to your hypothesized proportion, right? And so this is from the hypothesized value. This area here is the p-value. I'm going to emphasize that it's the, or I'll add a little note here that it's the one-sided p-value. And just for simplicity's sake, let's just consider the one-sided p-value for now. And so the p-value is the probability of seeing a p-hat as extreme or more extreme than what we saw, than what we saw, assuming H naught, and H naught would be something like P equals P naught is true. Okay, so that's going to be really important. Assuming that the null hypothesis is true, that's why we have to state our conclusion in terms of, do I reject H naught or not? Or do I not have enough evidence to reject H naught? And so it's going to be the p-value is the area in the tail. Okay, something as extreme or more extreme is the area in the tail. How we find that area, we're just kind of skirting around, but you might remember, you know, using a Z table or something like that. But the reason we can't say that we accept something, we don't accept H naught, we don't accept HA, is because there's a p-value probability that we're wrong. Okay? So we can never accept, and maybe I should write it properly, a hypothesis, because there is always a p-value probability of being wrong. There is always a p-value probability that we are wrong. Right? So that's the tricky part, is because, so here we've got our hypothesized proportion, and so it's centered on our hypothesized proportion, but then what we know about these normal distributions is that they never close on the axes, right? And so there's a little bit of space, so a little bit of probability, because the probability is the area under the curve. So there's a little bit of space all the way to negative infinity and positive infinity, right? There might be scenarios where some values can't be less than 0, for example, and stuff like that. But in general, it just helps to think of them going to infinity. Okay, and so so that's really important, and that's why we can never accept a hypothesis, is because there's always a probability that we're wrong. We either have enough evidence to reject H naught, or we don't have enough evidence to reject H naught. Right? We're always kind of leaving the door open in case we're wrong. Right? Okay, good. What else did I want to do a quick recap of? You probably talked about regression. And that's really the only time that we have seen something where we're making predictions. And so if the goal of the analyses, or analysis, maybe if it's singular, if the goal of the analysis, maybe I'll say that, is to be able to predict values, whether they be future values or just predict values, we use regression, right? We usually use regression. So if the goal of the analysis is to predict values, we usually use regression.
What you said? No, just 1 second.
Oh, is there a question? Here's someone. Maybe not. Should I mute you? I'll mute you. I think it was an accident there. If it wasn't, let me know. Okay, so if we're trying to predict values, then usually we use the regression. Now, the simplest regression is, of course, simple regression, where we have one response variable or a dependent variable, depending on the terminology that you like, and we have one explanatory variable. And so simple regression is just, and maybe I'll say simple linear regression, is when we have some y hat, some predicted value of y is equal to, and it depends on, you know, how you like your formulas written out, but we can use b1x plus b0. We can even use betas. I like to have the x here, so whatever is attached to the x is, of course, the slope. And the x is the explanatory variable. Where y is the response variable. Or you might have used dependent and independent. Because I know Sean comes from a biology, a math, kind of biomath background, and they like independent, dependent. So I wouldn't be surprised if that's what he used in his notes. And then Jenna just kind of took over, but I like response and explanatory because I like to emphasize that the X and explanatory, it just kind of helps me remember where things go. So it doesn't matter. You can use them interchangeably. It doesn't. I've even seen some people call the Y the response variable and then the X the independent variable. That seems weird, but yes, you can do that. right? And then we have B1 is the slope, and B naught is the y-intercept. Okay, so we would use software to find the slope and the intercept and estimate them. And what we're estimating is the population slope and the population y-intercept. So those are going to be denoted by betas, beta 1 and beta naught typically. I like to have them in this order because I like referring to them as y equals mx plus b, so that's probably familiar. And we are just looking at a straight line, right? So so nothing crazy. So what I want to do is I'm gonna kind of stop it there, but of course we could extend it to multiple explanatory variables, x1, x2, x3, x4, for as many as we want. And that's where we're gonna kind of pick up, I think. I'll suss it out. We've got a test in between. And so what I want to do is I'm just going to cut it here for today. And then we'll have our review on Thursday. Okay. You'll work through the lab on your own on Friday, so that doesn't count. And we've got our test on Tuesday. So if you have any questions, let me know. Otherwise, I'll see you on Thursday. I'll stop this here.